Hello, I'm Adam Taylor and I want to talk to you today about a little robotics project that we've created using the AMD Xilinx GUI Robotics starter kit, the KR260. We've been working with this for a little while now and we've created a few projects with it, and one of the ones that I want to share with you today I'm really excited about. It is a simple robot arm that we can then expand to use the full stack that the GUI Robotics kit provides. So we can, at the moment, we're running in a bare metal, an application just to try out and just to prove that we can control the motors, the servos, the positioning, etc. Okay, but once we have that and that's all working, then we can expand it to work with higher level systems such as ROS2. So let's take now a quick look at our demonstration.
And as we see here, our application has the robot 6-axes all positioned nicely. And what we're going to do just for an initial demonstration is to show that end actuator being opened and closed. We can see that end actuator being opened and closed. We're controlling that via software, which we'll see in a minute. And we can position this to either be fully open, fully closed, or any position in between, given the handling characteristics necessary. We do this and we can command this using a simple GUI interface at the moment, a simple command line interface, which allows us to select which one of the 6 joints in the robot and command it to a position, so left, right, nominal, or into an exact position within the plus minus 90 degrees that the servo can move to. Each time we get an acknowledge back, and that allows us to be able to script this and control this later on. Now, as we see this if we take a look at what's going on the actual servo itself, as we change these commands, we're changing the duration that the pulse width is provided to the servo to change the position of the servo. And we can see that changing here as we change from one width to the other. Now, the project was all created using Vivado and using Xilinx Vitus. We used a IP integrator approach, and one of the most important things in here, obviously, is the Zinc processor system, which contains all of the configuration for the ARM A53 cores, the R5 cores, and we connect, of course, and that's where our software runs, and we connect, of course, in there to the 6 AXI timers that we have and the PWM outputs. In the software world in Vitus, we created a very simple bare metal Vitus application that comes in and runs on a platform that we've created. So the platform's created from the XSA, exported from Vivado. And in here, we've created a main function, which allows any position of any joints to be updated. And then it updates the appropriate PWM on a infinite loop. If you'd like to know more about how to do this, then please take a look at the Hackster project. There's a full project there showing step-by-step guides on how to create this project, the theory behind control of them, the servos, the single stepping, all the way through to the constraints, the application, working with the GUI onboard, and downloading this and getting this all up and running and working.